One of the rules that you learned in Algebra 1 is that you can't leave a square root in the denominator. And that's what we're going to talk about next here. Right up here, though, that you can't leave a square root in denominator. Now, it could be any type of root. It doesn't have to be a square root. You can't leave a cube root. You can't leave a fourth root. You can't leave any root in the denominator at all. So what we call this process is rationalizing. Now, if you had me in geometry, we did discuss this, and if you had an Algebra 1, you definitely discussed it. But it's the same idea with, remember how you couldn't leave I in the denominator? Just like you can't leave I in the denominator, you can never leave a square root in the denominator. So you're going to have to rationalize it. Let's go ahead and practice a couple of these. Look at the problem 5. The first question when you have a problem like this, okay, you're going to ask yourself, can I cancel anything? Write that question down. That should always be your first thought. Can I cancel anything? Let's just say can. Can I cancel anything? In this problem, does 5 and 12 cancel? No. Does x cancel with y and z? You're going to write no. If you can cancel, though, you're going to do that. Now what I would like you to do is take this and make it two separates. So I want you to get the cube root of 5x squared on the top, and on the bottom you're going to make it the cube root of 12y squared z on the bottom. Now in this problem we are talking about cubes. Okay? So here's what you need to do. Obviously the bottom is not okay. We need to fix the bottom. Look at the questions. You have to kind of mentally check yourself. How can 12 become a cube? Write that question down. How can 12 become a cube? Well, let's look at the cubes up front. I have 8. Well, 12 definitely cannot become an 8. I have 27. 12 can definitely not become a 27. And what about 64? Well, let's try it. 64 divided by 12. Nope. Can 12 become into 125? No. What about 216? Alright, if we do 12 times 18, we'll be okay. How can 12 become a cube? 12 times 18 is 216, and 216 is a cube. Now let's talk about this. How can y squared become a cube? Well, if you do y squared times an extra y, that'll give you y cubed, and y cubed is a cube. Next question, how can z become a cube? Well, z times z squared would be z to the third, and z to the third is a cube. Alright, so what I'm going to do is I'm going to circle the things that we have to change it by. I'm going to multiply it by an 18. I'm going to multiply it by a y. I'm going to multiply it by a z squared. So I want you to go up here, and just like we did for imaginary numbers, multiply top and bottom by the same thing. Watch carefully. On the bottom, I need to multiply by the cube root of 18, y, and z squared. On the top, you do the same thing. Let's go ahead and do the bottom first. I personally think it's easier. The bottom becomes the cube root of, put your little cube there, 12 times 18 is 216. Y squared and y makes y cubed. Z and z squared make z cubed. And now let's do the top. Put your cube there. 5 times 18 is 90. X squared comes over. Y comes over. And z squared comes over. Keep moving on and fix the bottom. The cube root of 216, here it is, cube root of 216 is 6. The cube root of y cubed is y. The cube root of z cubed is z. The top, you ask yourself, look at 90. Do any of these numbers go into 90? The answer is no. So 90 gets carried over inside. Can you pull any x's out? You have 2. You need 3. Nope. Can you pull any y's out? You have 1. You need 3. No. Can you pull any z's out? You have 2. You need 3. No. That is called rationalizing the denominator. We got to practice it again on Got It 5. Alright, 7 and 5 does not reduce, neither does x and y squared. So we're going to ask ourselves these same questions. How can 5, it's on the bottom, become a cube? Well, let's go to our list. Does 5 go into 8? No. Does 5 go into 27? No. Does 5 go into 64? No. Does 5 go into 125? Yes. 5 times what, though, is 125? 25. Ready? So write this down. 5 times 25 is 125, and 125 is a cube. Next, how can y squared become a cube? What if you do y squared times y? That is y cubed. And y cubed is a cube. So here's what we're going to do. Multiply by 25 and by y. Go up to this problem. Let's rationalize our denominator. The bottom is what we're concerned with to start. We have to multiply by the cube root of these two items, 25 and y. Remember, the top has to be the same. Let's multiply. Let's do the bottom first. On the bottom, you keep your cube root. 5 times 25 is 125, which is what we wanted. Y squared times y is y to the third. On the top, 7 times 25 is 175. X times y is xy. Let's keep going on. Let's do the bottom. I think it's easier. The cube root of 125 is 5. The cube root of y cubed is y. On the top, we always need to double check. Do any of my cubes go into 175? The answer is no. So 175 travels over. What about x and y? Do we have enough to pull any out? The answer is no. We do not have enough to pull any out. That is called rationalizing. Part B doesn't matter because I didn't give you multiple choice. Alright, now that's the lesson overall, but just a couple of key points. Number 1, at the end, always check for perfect squares and cubes that you may be able to pull out. So at the end, always check for perfect squares and cubes that you may be able to pull out. Number 2, never leave a denominator with a radical. Number 3, be careful to always check your variables. For example, if you have the cube root of y to the 5th, make sure that you think to yourself, that's 5 y's, 1, 2, 3, 4, 5. How many groups of 3 can you pull out? You always have to simplify that and write what's left over. Other than that, that's pretty good. But number 4 is probably the one that throws most people off. In fact, I had to redo one of my videos. Always check index. Look for squares or cubes depending on the index. The index is 3. Don't look for squares. Okay? Cubes is if you have an index of 3. Squares is if you have an index of 2.